Welcome, ladies and gentlemen. Good afternoon from Berlin, from Tehran, from all over the world, and wherever you are in the world. We hope that you are well and staying healthy. Welcome to the Global Young Academy virtual satellite panel on trust in climate science. My name is Leila Niamir. I'm a co-lead of Global Young Academy Trust in Scientists Working Group. And it's my pleasure to open this year Global Young Academy International Conference on Young Scientists with a focus on trust in science. For this event, we are actually expected about 100 registered participants. We had a registered participant from all over the world, about 42 countries in 6 continents, which is great. And so I'm very much looking forward to the vibrant and fruitful discussion in our discussion panel. Please kindly notice that this event is recorded, and feel free to use hashtag GYA Trust Climate Science for this event in Twitter. And also for your questions basically for question and answers, we are using for Sildo platform, sildo.com. You can enter the code 349, which is also in our slide. Next slide, please. Perfect. First, let me briefly introduce Global Young Academy, who we are and what we do actually. The Global Young Academy includes no more than 200 early and mid-career scientists from all disciplines worldwide. Members are selected based upon an approved track record of outstanding contribution to the science and their commitment to public service, making a difference in the world and society. Our vision is science for all, science for the future, and the Global Young Academy gives a voice to young scientists by providing a rallying point for outstanding young scientists from around the world to come together to address topics of the global importance. In addition, Global Young Academy plays a facilitator role for growing networks from national young academies worldwide. Currently, we have 43 national young academies and 10 similar bodies. Next slide, please. Each year, we in Global Young Academy organize an international conference of young scientists, which brings together all renowned scientists and GYA and National Young Academies members to address the topic of the global importance. This year will take place online on the topic of trust in science, and this virtual satellite panel opens this year focus on trust in science with a close look to the climate science. We would like to understand which perspective do different areas of science, scientific research offers to encourage a better understanding of the climate change and its implication for human development. What do the applied science contribute to conversation with possible solution to prevent future global warming or adaptation of the technology? These are 2 main questions that we want to address, and that's why our scientists in this panel will share their view from broad range of the scientific disciplines and their experience and discuss ways to increase trust in climate science through global sustainable development. First, we will have our speakers, we will hear the speakers talk, and after that, we will have an interactive and live discussion between participants and speakers. So please use the link that we will send for putting your questions, and also you will be able to vote for the question that you would like to answer faster or earlier than other questions. And if you would like, you can add also your name, that when we have a discussion in our discussion panel, we can add you to the panel and you can talk lively with our speakers and discuss. I'm super excited now to have our speakers, introduce them. I mean, all of them are well known, but let me briefly introduce each of them, that they will have a very nice, they will share us a very their thoughts. First, I would like to introduce Professor Anjte Boetius. She's a director of the Alfred Wegener Institute of Helmholtz Center for Polar and Marine Research. She's a professor of geomicrobiology. Her research focus is on marine and polar sea ecology. And we are super happy and excited to have her. Thanks, Anjte, for accepting our invitation, and welcome to our panel. We were also happy to welcome Professor Gerald Höck, president of the German National Academy of Science, Leopoldina, on board. But unfortunately, we have informed that he wouldn't be able to join us because of the health issue. From here, we wish him speedy recovery, but kindly Professor Boetius will cover and will talk about also from his perspective on this topic. I also would like to welcome Professor Dr. Michael Saliba, the director of the Institute for Photovoltaics of the Stuttgart University, with a dual appointment as a head of the Helmholtz Young Investigator Group, front runner at the Research Center Jülich, Germany. Michael is a member of the Global Young Academy since 2018, and he's a co-chair this year. And also, he's a member of the board of the Young Academy, the National Young Academy of the Germany. And his research focus is on a solar cells technology for sustainable energy future. He received many prestigious awards from the Germany Research Foundation, which is usually awarded to the early career researchers in a recognition of their outstanding achievement. And also, he named as the world's 35 inventors under 35. We are very happy to have you, Dr. Saliba, here, and welcome. I would like also to welcome Dr. Leena Srivastava. I hope that I pronounced correctly. She's a Deputy Director of General for Science at the International Institute of Applied System Analyzing, GYA, in Austria. She was a Vice Chancellor for the TERI School of Advanced Studies in New Delhi, an interdisciplinary higher education institute focused on sustainable development. She worked for more than decades on maybe 3-4 decades on research in the area of the energy, environment, climate change policies, and highly engaged with the climate and sustainable development issues through the participation in various boards, committees, and advisory roles and international organizations. We are very looking forward to hear your experience and great talk. Thanks for accepting and welcome. I also happy to introduce another GYA member, a very excellent researcher, Fernanda Werneck, Dr. Fernanda Werneck. She's a head researcher, coordinator of scientific and biological collection program at National Institute of Research in the Amazon, Brazil. She's also the visiting professor at Harvard University. Her research focus is on biogeography, evolution, and effects of the climate change on biodiversity. She is one of the winner of the oral UNESCO International Rising Talents for Women in Science, and she's a member of the Brazilian Academy of Science, and she joined the GYA as a member in 2019. We are so happy to have you, Dr. Werneck, and welcome to our panel. Perfect. Now I'm very happy to see all these incredible scientists in one frame. So cannot wait to hear and learn from each of you.
Hello. I hope you can hear me. Yes,
Perfect.
so I just heard that Gerald Haug cannot be here. I work with him closely in our National Academy Leopoldina, and we have currently also working groups together where we discuss how to share expert knowledge, how to improve science communication, fact-finding, and all of that in climate sciences. So I can just kick off with a couple of short slides. I know that each of us has 5 minutes, and my theme is actually the oceans. But I would just like to get you into the mood by looking at one problem that we have from our science. Gerald Haug stands for climate science, paleo, geosciences. And so I'll do that for a short moment.
Thank you so much. We are looking forward. Floor is yours.
Let's see. So when we discuss trust, I would like to start off with one short statement of the responsibility first for scientists to have trust and communicate. That is in the framework of our national funding agencies, who gives us certain best practice suggestions for our role as scientists. And in that you can see, and that's how we act as much as possible in very different questions, that science serves to increase knowledge and has a duty to promote human well-being and the protection of the environment and other values. So as experts, we are supposed to share our knowledge and to provide also risk assessment based on facts. That is a best practice for scientists. Hence, the big discussion that society and politics often has with us. What is our role in science? Don't we have to be very neutral? Can we take a stand? Can we actually express and recommend? Can we do prognosis for a future that is uncertain? All of these questions are answered with yes, if we keep these best practice principles. And of course, the National Academy works with these and along these, though we have currently a very high-level debate with the media to clarify our role as experts and as policy advice provider for politicians in the corona pandemic. I would also tell you very briefly that for us, trust is, of course, a very specific set of mind. When you look up what trust actually is, it is a certain state of mind, a certain psychological conclusion that the individuals take and societies or collectives can take towards different societal actors. And to have trust in science actually means several things, that the people trust in a scientific method and culture, and that the people also trust in the position scientists takes. And we have to take that from two sides when we think about our role as assessing risks. So on the one hand, the people have to trust us that we act on their behalf, that we respect the welfaring, the well-being of society when we recommend, when we speak as experts. On the other hand, we scientists might lose trust if we are not taking a stand, if we are not documenting to the best of our knowledge what risks are ahead. And that's a very fine balance we have to seek: trust in methods that are neutral, trust in an open international culture of sharing. On the other hand, the trust that the society has in us doing the best for the society. Trust in science never means that science has to be 100% of the same opinion. This is often totally mistaken by media that report, oh, we don't have to trust science because only 10% of the scientists believe it is so-and-so, or 90% of the scientists believe it is so-and-so. So this democratic counting of what scientists in the majority think or not think, or say or not say, is not an argument, not an indicator of trust. Okay? And so for climate specifically, what Gerald Haug works on as a paleoscientist is to earn trust by assessing the Earth state, diagnosing the Earth state, and making recommendations, also synthesizing warnings for a better future. Note that for climate sciences, it is often forgotten that the first scientists had already warned as early as 65. In fact, the first understanding that there's something can go wrong with our atmosphere and the way we deal with the environment dates back to Alexander von Humboldt and Arrhenius. But in 65, the first set of scientists have warned the president of the US that we cannot afford blowing CO2 in the atmosphere because of global warming effects. And afterwards, when first everyone was on one page in the commissions, there was the split between oil and gas industry that paid people, so-called experts, to tell something different. We know this today. All of the documents are open, and it has been concluded that we had lost decades, really, with the war against science. So what is so interesting in climate science and trust? There are underlying phenomena in Earth that makes it really difficult to provide a simplistic diagnosis of how Earth will behave. And that's the work that Gerald does. And he would speak on behalf of that work. And I'll give you just one example that you see here. On the left side, you see the Keeling curve, CO2 emissions, dealing with climate, by just measuring the amount of molecules, CO2 molecules in the atmosphere. This is done since the early 60s, and you see this curve. So no one actually doubts that we can measure CO2 in the global atmospheres. There are many observatories, many points where we measure this CO2 in the atmosphere. We measure it in the oceans. Hence, we can have a budget of where the CO2 is. What is doubted, though, is the direct correlation with Earth warming, with climate warming. On the right side, you see such a task for Earth scientists and physicists and chemists. You see the yearly global temperature, and you see the CO2 concentration curve. And so for our times, just since the 50s, since we've entered the Anthropocene, we conclude that there's a very, very high correlation between the two. It cannot perfectly be assumed that throughout the Earth's history, with all of its variation, also without humans, there is a direct correlation between temperature and CO2, and scientists are very honest about it. But it makes communication really hard, that you cannot simply pinpoint to such a direct correlation. Thankfully, we have methods to directly measure climate warming effects of CO2 in the atmosphere, so we have gotten rid of the idea of some that we have no link between CO2 and warming. So the great work that all Earth scientists together have provided is basically shown, and I'm sure Gerald would have talked about trust in science and conclusions and prognosis and diagnostics here. And I end here immediately with just saying for climate and climate research, we are now so far in Earth system science that we can go back almost 60, 70, meanwhile 90 million years in Earth history, and we can try to understand the different states of Earth, hot or cold. We can look at the transitions between the two, and we can warn society that at CO2 levels we are entering, that you can see here on the right side, we might get into Earth system states due to warming that will melt all the ice we have on the planet over very long time scales. And that's a super high risk that we have to alert society about. Hence, experts have proposed certain goals. For example, how much CO2 can the atmosphere carry? How much warmer can Earth get before we get into a runaway circle, for example, with forests burning away, droughts causing also poverty and lack of food, increase of hunger, and all of those things. But underlying to earn the trust in society are two things. That we get the record of Earth system states straight, that we understand tipping points and threats that the Earth system hosts. On the other hand, that the society can trust that we climate scientists have the means to do a diagnosis and have the means to do a prognosis, meaning predict the future that comes and the link to our behavior. And in that, there is a lot of uncertainty. Just note that in the recent years, we have come together again and again as scientists to say we can be only so and so certain that we can keep the 2 degrees goal if we continue emitting CO2 as we do. But we have also made very clear that there are potentials of human society to change the path we are on. So the trust that we want is the trust that we do our job as scientists and warn and show the risks and calculate the different paths and find technologies for another path into a future we need. That's a very short intro to what we need to discuss about trust in climate sciences. And we are very, very clear, and look at IPCC reports, expert reports, we're very clear with uncertainties that we have with understanding and prognosing the behavior of the Earth system as a whole. So I jump to the oceans now? Or are there intermediate questions?
Yes. Yeah, we are waiting for that. Yeah, please.
Okay. So in the second part, I would come in now as an oceanographer and also biologist. And I was asked to put the perspective of the oceans forward in a very short wrap-up. As I've just defined various questions of trust, there is a third level of earning trust that I find very interesting and also sometimes threatening. And that is if our scientific knowledge is used to propose goals, political goals we all agree upon, like the SDGs, then those are science-based, those are based on facts. We say we should not have a warmer planet than 2 degrees, we should not warm the oceans to 2 degrees, we should not pollute or acidify the oceans. We put a lot of goals based on scientific facts forward. However, in what role are we scientists in when none of those goals are reached? We are the experts. We have said this is good for us to do it that way. But if society and politics fail to provide a document or provide the indicators that we are on the right path, as scientists, as experts, we get into a difficult position. There is evidence that since the Millennium Goals, since the SDGs, since the Paris climate negotiations, CO2 in the atmosphere and in the oceans CO2 emission has not come to a stop, have not changed the path. The only evidence that we have that CO2 is not as strongly as emitted as before is the effect of a virus on human society. The virus has decreased CO2 emissions by 8% in 1 year. And the other evidence we have from earlier times is any bigger crisis on humans has stopped the path with CO2 emissions that we're on, but after the crisis was ended, it would pick up again. So especially for ocean sciences and trusts with dealing with ocean knowledge, I would like to say that the difference with atmospheric sciences and paleosciences is in the oceans, people feel less at home, usually, at least Western civilized people, and politicians feel less at home, less literate than with the atmosphere and climate and weather that everyone likes to speak about. That gives us a special role as ocean scientists. It is part of our fight and struggle for trust that we increase ocean literacy and ocean knowledge. Hence, one of the key ocean SDG 14 goals is improve knowledge on Earth for everyone. Improve the availability of methods, data, and technology is also written up as part of the UN decade goal. Just improve knowledge about oceans. When we then turn to the oceans and realize that some people absolutely depend on the oceans and have their own traditional knowledge with oceans, then we find different societies to whom the ocean is not a faraway ecosystem that we might protect by putting a fence around a certain place, but it's actually a place they live from. What we Western industrialized countries often do not realize is how important the ocean and the productivity of the oceans is to a third of the humans on Earth. A third of all humans on Earth, actually more than a third, have their major protein intake in their food from the oceans, from fisheries. There is 10% of our global society, of global humanity, that lives about 100 meters away from the waves, from the oceans, without dike or without any infrastructure protection. There is evidence already that the oceans have turned, are no longer a pure wilderness without human footprint. And this, for example, has to do with their rapid warming, their rapid acidification, their pollution, their eutrophication, and their overfishing. These 5 observations that scientists have put together, similar to the climate synthesis, we have ocean syntheses and various NGOs and policy advice and national academies, the G7 conferences, the G12 and the UN. We have various platforms to put together ocean synthesis. And we have concluded for the oceans that climate change, overfishing, and pollution are all immense threats to the oceans. We have formulated goals based on the scientific facts, but all of those indicators are in a really bad shape. They have not been respected, they have not been reached, similar as for the climate goals. So that the situation that we're in with oceanologists, we have to take, to earn our trust that we should have as scientists, we have to be louder, speak up more clearly about the threats and the damage that is done with the oceans. Note, and here I'm ending then, that 2 of the very important tipping points are very early, probably the earliest tipping points to reach us. That is the decay and the bleaching of coral reefs worldwide. We are already at 50% losses in the past years, predicted to have 99% losses of coral reefs till the end of the century. And note that the sea ice decline is also about reaching half in summertime compared to before 1990s. And predicted that we are the last generation to see a summerly ice-covered Arctic within our lifetimes. So these are quite dear prognosis of the Earth system state. We have to say that we have a threat of losing trust of society if we put out stronger and stronger goals and not able to show by scientific facts that we are keeping the goals, that we are moving on the right path. Hence, some people think that scientists have become alarmists because we are painting this picture of a dark future if we are not turning the path towards a more sustained future. Thank you.
Thank you so much. It was amazing. I mean, a lot of food for thought. I mean, I was just making notes, and I have a lot of questions. And thank you so much for sharing all this experience and very important points that we will continue with the talks, and then we will have a huge amount of the time to discuss in detail. Thank you so much. So I would like to ask our next speaker, Dr. Michael Saliba. He will talk more on now on a technology perspective and solar technology. So we will get all these views, and then we will discuss in our discussion panel.
Yeah, thank you.
The floor is yours.
Awesome, thank you. Let me just quickly share my presentation. Can you see it? Okay, great.
Yes, perfect.
Yeah. First of all, thank you so much, everyone, for being here, especially for the GYA office for organizing it so well. That's with Beate Wagner and Jennifer Plowell, and also for everybody for agreeing to be here today. There are also a lot of members of the executive committee here from the GYA. I saw Robert Lepenis already, my colleague, co-chair Anindita Badra as well, and I hope I haven't forgotten anyone. But yeah, it's great to see such a good turnout. So Anjte Boetius wrote very nicely. Well, it's not nice what she talked about, but she stated it very nicely, how we get into a very difficult situation with the climate change. And I'll give you just a very brief overview on like a possible technological solution towards it. And you see it here on these slides. I mean, one thing that is very important is sort of our energy intake. And you see it here on this graph. It's a little busy, but essentially, as like a world population at the moment, we need like, let's say, X terawatt hours per year, meaning a certain amount of energy. And in the next 40 years or so, we are increasing. I mean, the trajectory is only picking up, as Anjte Boetius was saying already. We are increasing in our demand. Even if there is a dent by something like the virus, it picks up usually afterwards. People, when you create more energy, usually they find also ways to waste it, you know. And one interesting aspect is, of course, that a lot of the energy sources we're using on the bubbles here, they are limited. I mean, coal, uranium, oil, natural gases, and so on. And plus, they are producing a lot of harmful CO2. At the same time, however, the real question is, why aren't we using this huge bubble here which is the sun, right? I mean, it has more than enough to cover everything. 1 hour of sunlight would be enough to sort of like provide energy for an entire year. Okay, so then the question is, why aren't we reaching out for it? And it's really sort of something that people have dreamt on for a long time already. And you see it here, it's a very ancient dream. You know, how can we make the sun available to us? Even the old Egyptians have thought of this as well. I mean, this is more battery research, but let's say the spirit on how to harness the energy of the sun has been an old one for humankind. And the real question is, how do we get to a disruptive technological change here? Because at the moment we are locked into oil industry, our cars are run by it. It's very difficult to think of anything else. And there's an interesting picture here. This is, I think, somewhere in New York in 1900, and you see all of them used horse carriages. There are horses everywhere, apart from one pioneer, so to speak, who's using a car, a horseless carriage. So he was kind of the freak in this picture. But then only 13 years later, it's the exact opposite. You know, there's one person here, it's a bit difficult to see, using the horse. All of a sudden, everything has flipped around because of all the advantages of using a motor instead of a horse, right? So within 13 years, a disruption was possible. And I believe, also looking at the most recent climate data, that we need to think more along this line. You know, how can we change something on a fast timescale? And this picture is here to show you that this has happened for certain technologies in the past as well. And how can we facilitate a similar process for energy as well? And then the question, in a way, is, can we manage to get from this energy production from like fossil fuels towards this situation here, where we have renewable energy? I mean, I'm doing solar cells, so obviously I'm thinking a lot of that, but there are other possibilities as well, tidal energy and so on. But nevertheless, how can we do it disruptively and quickly? And you can see it here. That's sort of like the main technology used for solar energy. It's silicon, okay, the same stuff you use in your computer chips. And silicon has been optimized very well in the last 40 years. Okay, so we're already reaching the physical maximum of what silicon provide in terms of energy. And at the moment we are approaching the upper limit, you know, and how can we improve something as established as silicon? And here again, what kind of out-of-the-box alternatives do we have? And something came up very recently, so-called Perovskite solar cells. Gerald Hauke would have known them because it's a geological material originally, and one adaptation of it has come up like a sensation in the last 10 years and went from 0 to almost hero in a very short time. This has never happened for any solar cell material in the past. And it's also indicative of how quick science has become in terms of developing new materials. And I'm not going to bother you too much with the details of this material, but it's a very interesting group. You see it here. That's something we took at Oxford at the time. It's a liquid which is deposited as a thin film, only hundreds of nanometers thick. And this film here is already sufficient to be a solar cell. So it's produced very quickly and not as laboriously as you would do with silicon. And that's the kind of stuff we're dreaming of. You know, how can we use these kinds of innovative materials to really trigger a solar revolution? And you see it here. These new materials are useful. They are so light, they can be suspended, for example, on a soap bubble or printed like a newspaper. So a completely different concept in a way. And this opens many possibilities. One of them being that this new material can also be used with established silicon as well, in order to trigger this disruption that I've talked about earlier. The theoretical maximum of silicon is at 33, but putting a new material on the top could really like get us to a new sphere. You know, like a small change, putting a thin coating of this new material could help us to make solar energy very profitable. And that leads me towards sort of the end of this little input. One aspect is, how can we facilitate data sharing across diverse scientific communities in the future in order to develop these new materials? Perovskites are one of the most popular examples at the moment, but there are more, of course. Then how can we flip the script? How can we really have like a disruptive future? And here we need to make renewables profitable, okay? And one aspect of it is to include the externalities. I mean, of course, the climatologists know about this, but CO2, dumping it into the atmosphere, costs us nothing at the moment. And that's part of the issue why renewable energy isn't as profitable as it could be. We need new strategies as well. You know, here it's a decentralized energy production in the future as well. Sorry. And we also need new financial models to incentivize nations as well. That brings me to sort of the questions we could like discuss a little later. How do we facilitate a renewable energy revolution in the future? How do we establish more interdisciplinary thinking? Because I'm a physicist by training, thinking of semiconductors and how to turn them into solar cells. But obviously, I feel I could also say something to Anjte Boetius as well, because she's thinking from it from a different angle. And my background isn't in economy, but that seems to be also very important at the same time as well. Development aid also seems to go into it. Sociology, how do we increase the acceptance? So I think it's very important to bring all these loose threads together. And I thought the earlier input was very nice, because at the same time, it puts scientists into this awkward position to almost be morally obliged to become activists in a way. And, you know, how do we deal with that? Is it okay? Maybe we need philosophers to help us here as well, what can and cannot be done. And then the last point, how do we increase the trust within the public is also very important. Believe it or not, but some people are also very skeptical of solar cells. You know, I mean, we could say, okay, you shouldn't care about these people, and maybe you shouldn't, who knows? But in reality, you need to understand the fears here. You know, and you see it, I think, very clearly with this vaccination at the moment as well. You cannot simply tread on the fears of people. You know, you need to understand why people are so reluctant, because otherwise it undermines the efficacy of your measure as well, be it vaccination or renewable energy. If people do not buy into it, even if their arguments from your point of view are not correct, it will undermine the entire operation. And I think that's something we need to keep much more in mind in the future as well. And of course, and with that, I want to end here as well. One central role goes towards the young scientists as well. You know, they have a much larger stake in the future to an extent, just age-related, let's say. But even moving away from that, of course, it's also on them to change the curricula needed in the future as well. The way I studied physics didn't include many of these topics, but maybe it should in the future. And here, I think the young scientists and the young academies can play a crucial role as well in order to bring this knowledge into the next generation as well. Activities like Fridays for Future are indicative of that as well. I think here, young scientists and the young academies in general can be very crucial in the future. And with that, a very crisp overview, I'd like to give back to the chairperson, to Leila. Thank you.
Thank you so much. Thank you so much. So we will keep going to finish and go to the discussion. It's a lot to talk. So we will now go to the area of science policy and science diplomacy, and how we can basically communicate with others. We will welcome Professor Leena Srivastava to give us the presentation. Floor is yours.
Thank you very much, Leila, and thank you to GYA for inviting me to share my thoughts. I do not have a presentation. I think this is a presentation of the next speaker. Thank you. I will just be speaking off the cuff and basically sharing a few experiences from my years of engagement with the climate problem and having worked quite intensively with the policy community and society at large. So to me, I mean, my presentation, I think, is going to be fairly simple-minded. To me, it seems that one of the reasons why we struggle with the issue of trust in the context of climate science is obviously because the topic which is at hand requires us to change everything that we know about life on its head. And the reason, as Anthea mentioned in the context of the pandemic, that we were able to get an 8% or so reduction temporarily to the emissions of greenhouse gases is because we put a halt to life as we know it. And that is obviously, from the point of view of society at large, a very, very difficult thing to digest, because, as I'm sure a lot of you will agree with me, you do not have the future mapped out to you. You know history, you know how we have evolved. And if we had continued in that direction with all the autonomous changes that are taking place, where we would have headed. But if you take a break, a pause, and reset and establish completely new ways of living life, then your future becomes extremely uncertain, and it's very difficult for the nearly 7 billion people on Earth to align with that future that does not have a precedence. So, in the context of climate change, the change that we are asking for is very wide and very, very personal. It is not something which is sitting remotely out there in the oceans, for example, that at least 2/3 of humanity is not really feeling connected to. They may still be dependent, but don't feel connected to it. So the climate change problem and the responses that are required for it are extremely personal. And that's why we got the statement from the US saying lifestyles are not up for negotiation. Then is the issue of, why should I believe you? Yes, scientists, you're giving me this information, but this science is not available uniformly across the world. There is a big divide between the developed countries and the developing countries in the understanding of that science. And we are still a far way away from embracing open science and open science methods. So this again becomes a major challenge in creating trust. If I have to believe somebody who is closer home, whose interests are aligned with my interests, I would likely trust the person a lot more than somebody who's sitting a few thousand miles away and has a lifestyle which is very different to what I am used to. Then, of course, is the issue of scientific convergence. I think Anjte once again made the point very nicely. So it's not that we necessarily have to speak in one voice, but we have to be able to explain to people in a language that they're able to understand as to why there are differences in the outcomes of our research and how substantial does that difference translate into in terms of action. So our inability to communicate the science and the divergences and the implications of the divergences to the society at large becomes once again a big barrier that is often understood to be a lack of trust. We need to recognize, which we don't do, that there is a huge diversity of audience out there, huge divergences in incentives, in the way that the communications are received by the people. So that again is a big challenge. And I would like to talk about or end this part on trust. I'll speak a little bit more on something else by saying that trust comes from empowerment. And we know that the world is very, very, very differently empowered. And unless we are able to bridge these divides, it's going to be very difficult to talk about trust. That's on the science part of it. When it comes to action, my question to you is it a problem of trust? Is it of acceptance of science? Or is it, to be provocative, lethargy, that you do not want to act? So I believe strongly that the problem is more on acceptance of science rather than trust of science at an action level. And why in my mind is this acceptance difficult? I'll just take 1 minute to give you examples. From a policymaker's perspective, we have to be able to, set an alarm for myself that I need to switch off. We have to be able to communicate to policymakers the solutions. If we tell them what the problem is and don't give them the solution so that they are seen to be dealing with the problem by their constituencies, they are just going to shun the problem itself, which is what we have seen in the context of climate change. So when we spoke to certain policymakers in the coastal areas of India and spoke about sea level rise and intrusion of saline water and implications for agriculture. They just said that we don't believe in the problem of climate change. But in the evening conversation, they said we are extremely worried about it, but what do? We don't have solutions. We can't build dikes. We don't have the resources. And we do not have other solutions that we can be seen to be engaging with. So this absence of the linkage between science of one kind to science of another kind that is working more at a grassroots level to the solutions, I think is a big problem. For society, we have to be able to make them understand their role and give them a choice. I was running a small program, not a very small program. It involved about 10,000 students from universities a couple of years ago, trying to get them to live the experience of sustainability. And I reached out to one of the major pizza making chains to say, can we please have green pizzas, because pizzas are loved by the 15 to 25 age group that I was targeting. And the only solution they could come up with was, we can give you a green box, or we can give you, some recycling, food waste management solutions. They could not understand how to make their pizza itself green, the product itself green. So if you're not going to be able to offer choices to consumers, then to expect them to change and be an active partner in the transition to sustainability is going to be nearly impossible. And finally, as far as businesses are concerned, I think what COVID-19 has shown us is that if you have the right kinds of level playing field and stressors that are created, industry can respond, they can innovate, that they can create new business models in relatively short period of time, but we have to be able to engage them in a fair manner. So I'll just stop with these messages. Thank you very much. Back to you, Leila.
Thank you so much. So we are a little bit behind of the schedule, so I will encourage to go to the biology and ecology perspective, and Dr. Werneck, the floor is yours.
Thank you, Leila. Good morning, everyone. Yes, come back a couple slides, because that's not the first one. One more. No, you're going down actually for the first one. Yeah, there we go. There we go. Thank you very much. Good morning, everyone. It's a real pleasure to be here. It's morning here in Brazil, and it's a pleasure to share with you this day and these very rich discussions. I'm a biodiversity researcher in Brazil and a member of the GYA, so thank you very much for the invitation. So next, please. I'm not used to having someone else. Yeah, there we go. So, well, we are here. It's no news to all of us that global climate change is, of course, a reality, and it challenges all forms of life on Earth, not only ours, but including ours. And we need to deal with it, right? And this study that I chose to start off, it's very interesting because it shows that even though the society perception on climate change is increasing a lot in recent years, these surveys, they show that the media coverage for climate change, it can be up to 8 times higher. It's the brown here in the figure, the top right. It can be up to 8 times higher than media coverage on biodiversity related issues. And that those two coverages, they are usually not correlated in the media, right? So in other words, this means that even though society or part of it knows that the climate is warming, it doesn't have a lot of idea on what the impacts of it's going to be on biodiversity, right? Next, please. And actually, biodiversity is very important because it can be seen as the basic units, let's say, in which the evolution of life on Earth operates. And it's very important, it's essential actually to preserve the diversity and complexity of all biological systems, the evolutionary processes that have generated these systems, but also potential adaptive responses to environmental change, such as climate change. In sum, it's very important to guarantee in the long term some indispensable ecosystem services that are usually taken for granted, right? Food, fresh water, biochemical properties for medicine, for example, and even climate regulation per se. And yet, next, please. And yet, what we see today is that biodiversity is under very high threats. So very recent reports, they show that up to 25% of the species, the global species, they are under some sort of threat. And more than 1 million species are under imminent extinction risks, and which is what we call this big biodiversity crisis. And the main causes to it are land use, right? Habitat loss through deforestation and fragmentation, and climate change. So next, please. So I, as you might have imagined by the pictures, I'm a herpetologist, which means that I study amphibians and reptiles, which are usually seen as the cold-blooded animals. But why is this relevant for climate research is that because they depend a lot on the environmental temperatures, that means that global and local temperatures, they might influence how they live and evolve, right? And I study these groups in the Neotropics, which is the most biodiverse region on Earth. And as you can see, have some very beautiful ecosystems and biomes, very rich in terms of species diversity. But we are also experiencing very high rates of deforestation and the combined effects of this deforestation and global climate change. So next, please. So in my lab, very shortly, what we are aiming to study. So we use integrated studies in which we collect ecological data in the field. So we do a lot of field work. For example, we study species distribution, their thermal preferences and limits to see how they can handle increasing temperatures. And we integrate these with genetic data or DNA sequencing that we use to study genetic variation and signals of local adaptation to climate selection. And we use those to sort of study the historical determinants of biodiversity patterns. So we look at geological time scales as well for these groups. But we also want to study this baseline of historical determinants of biodiversity to understand how climate change might impact these biodiversity patterns. And of course, with that, our main goal in the long term or in the short term actually is to provide some improved models, improved predictions of climate change, how these scenarios impact biodiversity, and support long-term biodiversity conservation initiatives that take into account this research we are generating. Next, please. So, of course, it's a long research agenda, and I don't have a lot of time to go into details, but I would like to bring two big or main findings of my group. And what would be that's shown lots of strong associations between climate impacts and ecological and evolutionary processes at these mega diverse regions. And what we have found is that while most of the species that we study, they are under very high extinction risks, some biological groups, they actually seem to be favored by environmental change. So there are some groups that seem to be tracking anthropogenic changes. And this is very important when we look at a long-term conservation of biological communities, because we need to look at these sort of winners and losers dynamics and how this might impact not only one species, but whole biological communities. And the other main recent finding is that we find a lot of intra-specific variation, which means within species or between populations of one single species, we find a lot of variation on thermal traits and genetic diversity that affects vulnerability and extinction risks, and also adaptive potential. So in other words, some regions or some lineages, they seem to be more vulnerable than others. And this is very important to account if we are looking at, let's say, evolutionary rescue, how different populations or geographic regions need to be looked under the microscope of biodiversity conservation, let's say. Next, please. So what is the main idea that I want to wrap and try of bring to the discussion is that not only these results from my group, but most of biodiversity related research, what we've been showing is that climate change and biodiversity loss, they are interconnected problems. And for such, they have interconnected solutions, right? So the best way to keep the climate health is to preserve the ecosystems and the biodiversity that kinds of retroalimentate them. So it's very important to increase this awareness to the public and to policymakers that these two look at the other side of the coin. So they are very interrelated problems, but they have interrelated solutions, and we need to look and try to make these links clearly for the general public and support more research related or biodiversity related research policies framework across the globe. So I think that's what I want to bring today for the discussion. I would like to thank everyone and looking forward for the next discussions that are coming up. Thank you.
Perfect. Thank you so much, Fernanda. And let's applause for all of our speakers that had a great good of thoughts and discussion. So before jumping to our panel of the discussion, we would like to ask you one question and get a feedback from you. That is, the question is that please go to the sildo.com, enter the code, and the question is that, do you think you have to be able to understand climate scientists in order to trust it? Please answer it, and also I would encourage to add your questions and vote to other questions, and then immediately we will start the discussion panel. Thank you.
To Leila, was this to me? I'm not sure. I'm not sure if the question is for all of us to answer or is just for reflection.
It's for all of the participants could answer the question. And so far we have about 12. So we will encourage people to answer, and then we will show the result.
Oh, sure. I could give some brief thought on that. If
I
it's
thought
fine.
that
So,
the procedure is first they vote, right? Then we see the vote, then we discuss, no?
No, this is just a quick questionnaire, and then we will go to the question panel. So this is just for getting the point of view of the participants. Yeah.
It's just food for thought. Right. So yeah, I think that we actually.
Fernanda, just a minute. Sorry, Jennifer, would you please show the result? So, as we expected, it's they mentioned that the hard to define the understand also is correct. So for now, also I would like to encourage people to we design a survey, a question And we would like to you to go to and answer that, not now, after the panel when you have a time. It just takes 5 minutes. My colleague will share the link in the chat in a few minutes, and we'll encourage it just a 5 minutes, and will give us the view, and hopefully we will get back to you by very nice discussion. So shall we start the discussion? I will look through the so I want to ask the panelists, did you see the questions or already is in our Silo? And there's a couple of the questions that the people vote. I will again put the link here that you can see. So Jennifer, or one of you, would you please also put the as a background the questions that all of us could see to save the time? That would be great. So till that.
Okay, I logged in. I didn't know we were supposed to log in, but I did that now. Yeah.
That's okay. So excellent. We have the questions. The first question is do you see trust as an obstacle, or rather than excuse in taking urgent action to combat climate change? Maybe you can, all of you could have very short answer, or one of you want to bring the more discussion, please go ahead.
Yeah. Sure. Okay.
Yeah.
Well, to the question number one, the trust, if you measure it, we take polls regularly in Germany about the trust situation with certain scientific themes, and it is really high with climate sciences, but has not led to the appropriate action in the government, or also not individual. So if we all agree that trust is a certain state of emotion, and if we all agree that the climate itself is not influenced by whether we have trust or not, or the temperature of Earth or the CO2 content, it puts trust into into a perspective. Everyone, and that's what the climate modeler says, uses cars and fully trusts in all the scientific simulations that are operating in cars. If the same simulations are used for climate models prognosis, as we have for brakes or autonomous driving, you could say it must be the same trust, but it isn't. And so trust is of course helpful, but it is not the absolute prerequisite. It makes it just very hard in any society if there's no trust in authorities and experts to get on, to move forward. So if politics say we can only act when we have 100% trust votes in society, then of course it is not possible. But I don't know societies that fully operate like this. So I would not worry too much about trust being an obstacle.
Perfect, thank you. Yeah, Leena, I can see just before you start, I want to say that the person or the people that want to discuss about this particular question, they can raise their hand, and then we can invite them to discuss with our panelists. Leena, please.
Thank you. I just wanted to reiterate a point that, science, when we talk about it, is an entire spectrum. So if you look at the IPCC reports, for example, the 3 working groups are reflecting that kind of a spectrum. So when we talk about trust, I think there are these different elements, but we do need to recognize that the policymakers do not see this spectrum as clearly as the people who are working on the science of climate change see it. So I think we do need to recognize that our lenses are different. And when we talk about trust, it need not necessarily be a problem of trust across the entire spectrum. It could be in one part of it, but it can get confused with something else as well. So I think communication is critically important, and we need science communicators to be stepping up much, much more aggressively than they have. There are times when trust is an obstacle, but there are times when it is this lack of understanding is also an excuse.
Yeah, Michael, do you want to add something?
Yeah, I think already the main points have been made. I completely agree that having a complete trust-based science where everybody understands everything in all details is not how we operate at the moment. So I think it's almost a fallacious argument to go into this direction. In no other area, like cars or elevators, we would insist on this degree of trust of the individual. And I mean, there's also a reason why we have a democracy which is representative in many countries. So we want other people to do their jobs as well. I mean, at some point you hand over this kind of responsibility and trust that the process will be working as well. And I find it kind of confusing that we do this everywhere, but in the most important question, which is our environment and livelihood. But let me bring another aspect here as well. Of course, there's a political component to it as well. There was a will for it, especially in the US, to go against this argument of preserving the climate for other reasons. I don't even want to go into it, And so a lot of the discussion that was put out there for political reasons. There is only a so-called controversy in the US because it was manufactured in order to enable business to run longer, which is if you price in the externalities no longer profitable, And so here we are talking all day about trust and stuff like that, when the other side fully well knows what is going on, but undermines the whole argument politically. And so I'm saying that because here maybe the correct discussion is not about trust, but about politics, And so that I think is a bit of a different angle. So we may be beautifully explaining everything, put up the best possible slides, but then the other side already says, I understand what you're saying, but I want to make a profit. And here we also need to know who we are discussing against, so to speak. So much from my side.
Perfect. Thank you so much, Michael. And then I would like to continue that also this raised in the discussion that the communication and open science and big data sharing that, Michael, I do remember that you also mentioned in your presentation, that there is a comment that open science alone is not sufficient to build a trust in science. I mean, in the perspective of our participant, Farah Otachi, she thinks that we do need popularize the science like culture. And also, do you want to give a feedback here or?
Yeah, I mean, in a way, it is, of course, very important, as the other experts have pointed out, this role of experts in democracy there's a big debate, I think, in all countries today with the pandemic as well as with climate. And as everyone has pointed out, you're an expert only in a certain narrow angle of the entire systemic problem that humans are in the Anthropocene. And so if you make very clear, where is your science? Where does your science start and end? What is your method? And then where you learn from other disciplines or experts, and what you could recommend in terms of having paths, transformatory paths or behavioral paths, what you recommend as scientists as a conclusion from having expert knowledge together, then you are safe and then you can build that trust. It helps a lot if the media, who are the third power in this, as we say, so science journalism is helpful in this regard because it's outside of the science operation. When we as scientists, for example, say climate change is dramatic, then some say, oh, you say that because you want more funds for your research on climate sciences. And so if you have a third power like science journalism that looks at everything together, doesn't discriminate according to organization or person, then of course that is very important in democracies and in building that trust. The idea of popularization is also an important cue. For example, at the moment we have a discussion, we have a film festival in Germany where we try to discuss with the media, with film and art and everyone, what's your picture of a scientist? What is that? So how do you depict scientists? Can they be heroes also? Are there women scientists? So that people understand you can trust in female scientific expertise and so on. So I find this a very important field that altogether has to do with trust. But trust alone, and that's, I think, the main point that we want to make with climate science, is not action. Yeah, we have a huge trust. So in Germany, in Europe, during the pandemic, 73% of the Europeans have voted climate threats as the biggest threats we have during the pandemic. So they apparently trust knowledge. Have we changed the behavior, the industry yet, or the goals of everyone? No. And so that's very important to keep those two lines of thoughts close together, but not confuse them.
Excellent. Also, this also leads to the when you in your presentation perfectly mentioned about the uncertainty that we should as a scientist we should look through that and report that and show the path what would happen. Also, you or other panels, would you like to little bit clarify or explain about the uncertainty in a climate that people are not familiar with, that how we can build the trust based on that?
So,
Yeah,
I
please.
think, yeah. So just a little bit on the previous point, and then maybe I will talk about uncertainty in a different context. I mean, I agree with Farah completely that open science is not sufficient, but it is definitely necessary. I think that is critically important. The second part I did want to mention, which builds on what Anjte has said, is that we also, as scientists, need to learn who is it that we have to partner with to ensure that our science has the outcome that we would like it to have. So, if we take an approach that says that I have done my bit and it's for somebody else to pick up, then I think we run into a problem because we all recognize that we have our backs to the wall as far as the climate change problem is concerned. And if we want to have the response from policy making and from society at the speed at which we want that response, then I think we have to join hands and do what is necessary for that purpose. And we possibly do not do that adequately. As far as uncertainty is concerned, I mean, yes, on the science part, there is enormous uncertainty, as Anjte once again very nicely showed in her slides when she was talking about the relationship between emissions of greenhouse gases and temperature. Can you just imagine trying to draw something like that with behavior responses? When you look at incentive structures, when you look at institutions and try and map that onto the responses of behaviors, it's a one, of course, we haven't done enough work on it, but then it's such a huge challenge. So that's what I mean when I say that you have to look at the entire spectrum and be able to move from the problem to the solution. Not move, but at least map. Thank you.
Thanks. Great for input. I just want to ask a participant to please raise the hand if you want to discuss and involve in the discussion. That would be very helpful. Also, you can ask your question yourself. But the popular question now is that since that Michael also talked about the role of the young scientists and organization or the academies like Global Young Academies role in trust in science. They asked that what Anjte or Leena have liked to be member of the GYA or Global Young Academy later after their PhD degree.
It was such a long while ago, and I'm really sorry I didn't have the opportunity. Would have loved to.
Well, when I was a PhD student and a postdoc, my entire interest went to being at sea, diving, counting animals in the oceans. I had no interest in politics at that time, I have to admit. It was more or less than being at sea and looking at the footprints of humans that had turned me into speaking out. So probably as a PhD student, I would have refrained from any membership. I did that. I was never a member of anything until later when I understood how important it is to be united, to meet people of different kinds and have a platform to express oneself. So this came to me very late. So probably if you would have asked me as a PhD student, I would have said, no membership. Stupid, huh? But I say that I because I want your trust, that I'm honest.
Cool. Also another point that raised a lot. I mean, I'm just also looking to the participant is things that we discussed about the interdisciplinary and collaboration, that how this could bring the or increase the trust in science. As we discussed, or I think it was in Michael's presentation, and that talking about that sometimes we don't know how to communicate to the other people. And also, I do remember that Leena mentioned that our audience is diverse. I mean, they are from the different perspective, with different knowledge, and it's very difficult to connect or to bring or show our knowledge. And it was interesting that Anjte also mentioned in a SDG regarding to the ocean, there was a thing that is improve the knowledge about this ocean and marine. So these are very important. So that brings me that we should think really about the collaboration and interdisciplinary. I also would like to have your input on how, for example, the social scientists, communication experts, or journalists could help us to go for in that way. I would be happy to hear your input. Yes, please, Anjte.
To improve trust and action, I've went to a different societal actor, and that is industry at large. So early on, I was involved in the UN program Global Compact, where industry and a bit of science, academia is put together so that industry can ask whatever they want to ask about knowledge and facts, and then conclude for themselves how it matters to their businesses, in my case, ocean businesses, to then draw action and say, okay, we bring this to the oceans till 2030 or so on. And that gave me a real new kick, because I understood if the same knowledge that I as an expert have and bring to the table is then repeated by an ocean industry, it builds a lot of trust in areas I cannot reach into as a scientist, because only the already convicted will listen to me. And so it is, as Leena said, the partnership. So whom we choose as partners to reflect our knowledge and have them express their insight or their abilities or their opportunities, that builds a really different type of trust to each other, but also a different type of power and force and activity that you feel. Then it feels really good if your science is reflected through the eyes of others, especially those where you think they are not giving enough attention to nature or Earth, planet Earth or so. So that's one measure I took.
Perfect. Leena, and then Michael.
Thank you. I think we definitely need interdisciplinarity as well as transdisciplinarity to be able to have effective solutions. I can give you a quick example from my own experience. I used to do energy economy modeling and at one point in time, and came up with a number of pathways for India on how we can reduce emissions of greenhouse gases, and found no response in government. They listened in a very interesting manner and interested manner, but did nothing about it. Then I thought maybe I'm not bringing out the economic dimensions adequately. So we did some economic analysis of the solutions that would have led to lower emissions of greenhouse gases. And still we found that there was no response really. And then we realized that when you went down to the field level, the solutions that you were putting forward were more likely than not to be accepted by society. Take, for example, cooking energy. Or even renewable energy, Michael. So we might say that it's a very nice renewable energy source with no pollution, and it is available throughout the country. Let's say solar energy. But the point is that people, A, may not be able to afford it, so it has to be accompanied by a lot of other things. B, your eating habits, your cultural differences as far as food consumption is concerned would possibly make that particular solution that you're coming out with in the form of solar cook stoves, just as an example, completely irrelevant as far as the people are concerned. So, unless, again, I'm going to repeat that we are able to understand the drivers of change and work backwards from there. So, you need both a top down as well as a bottom up kind of an approach to be able to converge on the solutions that are likely to lead to transformations that we want. Thank you.
Perfect. Michael?
Yeah, I think it's an important point to also have a reality check every now and then. you know, the way we study at university, often we have idealistic models and assumptions. You know, if something works for a small quantity, it's good enough to do a fundamental investigation, which I love as a scientist, of course. But then, you know, if you go to industry, you all of a sudden realize, how do we scale it up? You know, how do we get, for instance, solar power to everybody? And I think this really changes your research questions as well, even the way you teach, perhaps. So in the Global Young Academy, we had this energy initiative, I think, over a year ago. And I think this will be important in the future because we thought of changing the curriculum as well. And I mean, I don't know about the climate sciences, but having a curriculum would need to have subject matter for many sub-subjects, right? And so establishing it and having it quickly implemented at university is a real challenge as well. And traditionally, this takes years and years, right, to establish new knowledge within the curriculum. And I think in the future, having a quicker turnaround in including the most recent knowledge will be a particular challenge for increasing interdisciplinarity as well. So my feeling is, even at high school level, we should be able to implement this new kind of knowledge instead of like sticking with a 10 or 20 year delay to the older knowledge. And I believe technology here can be an asset and a benefit. I mean, of course, you know, every crisis is an opportunity, but perhaps we can learn a little bit like that from this virus corona pandemic as well. How do we get the newest knowledge, the best teachers to many, many classrooms at once? Because it is my firm belief that changing the curriculum towards more sustainability will be crucial too. I've learned with much interest, for example, in chemistry, when you study it, often the concept of green chemistry doesn't play a big role. Are there alternative solvent systems which are less toxic? Yes or no? And usually as a chemist, you would say, I don't care so much, you know, maybe. But establishing it from the get-go will be very important. And here, there I want to conclude with Antje's point, industry has already shifted. Industry is much more sustainable than most universities at the moment. Why? Because it's all about the money. You know, so they know there's an externality to pay for it. So they say we no longer will use these toxic components and solvents anymore. And we should implement that swiftly at university as well. Thanks.
Great point. Thanks. Fernanda, would you like to add? Yeah, cool.
Yes, please, Leila. So it's just like a general speak, touching a little bit of everything that was said, because I really agree with all my colleagues in terms of the question between is it a trust or is it just a policy decision, right? So I completely agree with all of you. And something that I would like to add is that how complex it is, these things in the global scenario, right? Because we are talking about countries that are looking at the perspective of climate change and climate science from completely different perspectives. And I think that these drawbacks in terms of policy and trust, they can go back way too fast when climate change is going forward way too fast as well. And we can just look at some of our governments and see this, right? So I'm talking from Brazil, which in few years we walked back like decades in terms of the trust that was being built in terms both of climate research and biodiversity research. So it's becoming almost like a resistance to keep doing science and trying to increase the trust in especially those sensitive topics, let's say for politicians, which is climate, which is economy and biodiversity in my case. So it's, I mean, what I want to say is that it's very easy to have big drawbacks. So it's important that solutions, they are really thought in a very integrative and global way, so we can protect those countries in these groups, these marginalized groups, in terms of producing science and doing it in an interdisciplinary way. So I tend to look at a very important, and this is why I'm really enjoying, for example, my time at GYA, because I'm a hardcore, let's say, scientist. I don't do a lot of policy influence, but I'm trying to do that more. As more I interact with my colleagues in Europe. And I've done my PhD in the United States, but I see that there is a lot of building trust from the beginning that I wish I knew better earlier and could be doing that. But yeah, that's my take on this. And also one thing that I think it's very important, resonating Michael's talk about, like small kids, and that we need to really emphasize is that the dichotomy between basic and applied sciences, it doesn't help, because it's very important that people are always, well, why do you do that? Why do you need to study this is too basic? How this reflects on climate change? And no, we do know that for getting into a point of developing a big technology, some very basic research needed to be developed in terms of materials or biodiversity or whatever. So that's very important, because once we start questioning, I know this is too basic, it's not applying, it's not generating cash or economy, then I think we are affecting the overall trust in science. So this more integrated view of the basic and applied and the regional differences, that's what I want to add. Thank you.
Thank you. Thank you so much. Unfortunately, we are running out of time. I would like to ask our speakers to just give us a sentence or a short tip or advice that how we can basically increase the science, increase the trust in specifically in climate science. Please. Yes, Leena, please.
So your question was, how do we increase trust in climate science?
Yes.
That's I thought this entire session was basically about that. But if we have to talk about it in one sentence, I would definitely encourage all the scientists on this particular program to look for an opportunity to engage with the real life problem on the ground. Even if it is a short exposure, I think it really changes your perspective. And I think that is extremely important.
Thank you.
For me, a big step, other than what I've just mentioned before, was to make people eyewitnesses of the change around them. As humans, we have this problem that we call shifting baselines, that our brains let us forget the type of environment, the type of situation that is good for us versus bad, and we can adjust very much as animal, more than many animals can. So if we remind people of what is good for them in terms and what they know is good, what smells good in nature, what tastes good, what is good, what did the grandparents say, if you make people eyewitnesses of change, of dynamics they might not want, and get their activity back and get their bondage with nature back, I find that a very important path that links also climate and biodiversity, which are to me linked in my mind and not separate items of planetary protection.
Perfect. Excellent. Michael or Fernanda, would you like? Fernanda, please.
Just as a wrap up, I totally agree with it. It's making people connections with nature, and it's very important. And sometimes some stuff like real close to society, it's being lost, and they don't even have this idea. So those images that we show, like the big glaciers in a couple of decades, they have a lot of impact. So making society part of the data generation, so science like commons, I don't remember the name, but including citizenship in science, it's very important. I would also say that we need to share both positive and negative results, let's say. So and that's something that when you are looking at adaptive potential, can species adapt to climate change, that's something sometimes I hear, why do we want to say this? Because it's kind of showing that there might be a response, but that's not the way I see. I think that we need to show both the positive and the negative results, let's say. And I agree that open science, it's very important. Show the uncertainties. All our areas have uncertainties. Climate, ecosystem research, biodiversity research, we are using proxies, but they all point in a common direction. So even if there is a little noise here and here with the uncertainties, they are pointing in a common congruent direction. So that's the big message that we need to stick with. So that's my take.
Perfect. Thank you. Michael?
Thanks. I mean, so many good things have been said. Perhaps I just add two things which I think are important to build trust. One is to maybe make it less about the scientists and more about the science, you know, so it doesn't become a huge ego tour. I mean, of course, there are many aspects to this argument, but I sometimes feel it'd be better to put more the science at the forefront and to depersonalize it almost, you know. That's one aspect. And the second aspect, reverberating with something that Leena has said earlier, show a little sympathy for people, you know, sympathy and empathy. I mean, you may have a very different lifestyle, and then you're teaching them on how to live their lives and stuff like that. Try to be sincere in understanding their concerns for not trusting into certain aspects of science, because from their point of view, that's their kind of truth. And that's sort of the obstacle towards getting a buy-in for trusting in climate change and climate science. And I think taking these concerns very seriously, taking where people are standing, what livelihoods are at stake, and maybe your difference between them, I think that's also extremely important. Instead of like, you know, as professors, as scientists, sometimes we preach above them, and that also causes a unique kind of antagonism. So out of spite, people may be resisting something that is very good for them, and taking the psychology into account, showing a little bit of sympathy, I think can go a long way in increasing trust in science. And then trust in the Global Young Academy as well, perhaps as a last argument. Back to Leila.
Yeah, thank you so much all for your great thoughts. And I think we all now is thinking a lot, and I will bring a lot later, because we are not just getting all the inputs. And it was incredible presentations, and which we think. So if I want to, very in summary, to wrap it up, is that we should also think, I mean, we always should think not only top down, but also bottom up perspective, to also involve all the kind of, not only the nudges, social norms, and changing their lifestyle, but also from the policy perspective, political perspective, that we talked about that. And more important, we see that what's the barrier of young scientists and scientists to reach the bring more trust and try to solve that, and encourage early career researcher and scientists to learn how to communicate. The science communication is very important, and in summary, science, policy, society interface is very important. We should learn how to communicate with the policymakers and how to communicate with the people or communities around us to bring this trust in our studies or research. I would like to thank you all for your great input. Myself, I really enjoyed, and I learned from each of you a lot. And we also prepared the survey. We would be happy if you could also fill out our survey. And last but not least, I would like to thank you, the GYA office, who kindly and incredibly support us to organize this meeting. It was the first kickoff of actually the conference, and it was thank you so much, Jennifer, Beate, Christine, all of you. I mean, it's that there's perfect. And if you want to get know more about the GYA, please visit our website. And I also encourage the young researcher to apply and join to the Global Young Academy, and to join together, collaborate together, and build the trust in science and be more visible. Thank you so much. Sorry for a delay, and have a good day, everyone. Bye-bye.
Bye-bye, and hello to Brazil. I love Brazil, and I miss it so much being there doing research.
We'll visit here next
Thanks,
time.
everyone.
Thank you,
Great.
everyone. Have a great day.
Stay safe.